As much as we would like to give it on the correct person, we have to take what they tell us. Which can sometimes work out as a good thing, but sometimes it goes the other way.
Oh yeah, I was watching the first until the second quarter with like 3 minutes left, and it was literally like dry paint drying, watching paint dry. I was like, this is so boring. What was it, like 9 and 12?
Yep.
I was like, yeah, I'm just gonna go sit down.
I think this is where we stopped yesterday, yes? Now, so we would set the two denominators equal to 0 and solve. Now I'm going to go on and give those to you. Those restrictions would be -5/2 and -8/11. Those would be the two values of x that would make that denominator be 0. Now again, the first thing we want to make sure before we start solving, multiplying anything, doing any of our steps, is we do need to make sure that the two denominators are factored as far as possible, that there's not any like terms, anything in common with either one. And as we look at both of these here, 2x plus 5, no greatest common factor, can't be simplified. 11x plus 8 is the same thing. So again, the first thing we want to do is simplify these denominators out. If we can multiply through and get the denominators simplified, that's going to make these easier to work with. So what's one thing we can multiply through to get the denominator simplified? Well, 2x plus 5. Now on the left side, the 2x plus 5 and the 11x plus 8 won't simplify, they won't reduce, there's nothing we can do with them because they're not the same. However, on the left-hand side, the 2x plus 5 over 2x plus 5 would reduce out completely. Well, the other thing we need is 11x plus 8. Because on the right-hand side, 11x plus 8 on top and bottom would reduce. And what that leaves us with is 1 times 11x plus 8 is equal to x times 2x plus 5. Now, we could have gone through the process of figuring out what the least common denominator between 2x plus 5 and 11x plus 8 is and go through that process, but this is the same thing. This is also helpful just in case we do have repeated terms in different denominators that we don't add too many. Questions on how we got to this point here? Now we need to start simplifying. On the left-hand side, we can simplify or remove those parentheses, nothing in front of it, nothing to be multiplied, so they're just going to drop. Now on the other side, the right-hand side, we will need to distribute the x. X times 2x is going to be 2x squared. X times 5 is going to be plus 5x. Questions on any of this here? Questions on this so far? Now, this is a little bit different from the ones we had previously, because this time we have an x squared term. We have this variable to a power greater than 1. And whenever we get these x squared, these quadratic terms, these cubic terms, we need to get this equation equal to 0. We got to get it equal to 0 first. So to do that, the first thing we can do is subtract 11 from both sides. So those would simplify, leaving us with 8 is equal to 2x squared minus 6x. Lastly, to get to 0, we would subtract 8 from both sides, telling us 0 is equal to 2x squared minus 6x minus 8. We've got to get it equal to 0. That way we could factor solve. In this case, because it is a quadratic, our x squared term, we can use the quadratic formula, completing the square, factoring, graphing, any of those methods would work. Now I'm going to factor this one here. Now the first thing we want to do is factor out the greatest common factor amongst all three terms. And because the greatest common factor between 2, 6, and 8 is 2, we can divide it out of all three terms, giving us 2 times x squared minus 3x minus 4. Now our x squared minus 3x minus 4 is factorable. So we'll set up our 2 sets of parentheses with 3 spaces. Since the third term is negative, our signs are opposite. One's going to be positive, one is going to be negative. Now the factors of x squared are x and x. And lastly, the factors of 4 are 1 and 4 or 2 and 2. Now, interestingly enough, we wouldn't want to pick 2 and 2 because of the signs, because x plus 2 times x minus 2 are actually our factors for our difference of perfect squares. So we're most likely going to need 1 and 4. And we can check and make sure these are the correct factors. X times negative 4, negative 4x. 1 times x is positive 1x. Yeah, telling us that if these are the correct factors, the middle term is negative 3x, which is what we wanted. So x plus 1 times x minus 4 are indeed the correct factors for this here. Questions on how we got here? Questions on any of this so far? Now we have 2 or more things multiplied together that equals 0. So one of them must be 0. So either x plus 1 is 0 or x minus 4 is 0. Because those are the 2 expressions, the only 2 expressions in this equation that we can actually make be 0. The 2, there is no variable with it. There's nothing we can do to make it be 0, so we don't include it. So now we just need to solve x plus 1 and x minus 4. With x plus 1, we would subtract 1 from both sides. Our 1 minus 1 would be 0, leaving us with x. 0 minus 1 is negative 1. So one of our solutions for this is that x is equal to negative 1. With our x minus 4, we can add 4 to both sides. Negative 4 plus 4 is 0. 0 plus 4 is 4, telling us that x is either equal to negative 1 or x is equal to 4. So these are our 2 solutions for this here. Questions on any of this so far? Are you ready to look at the next one? So the next one's a little bit different in that we have 3 terms. Because up to this point, we've only solved equations with 2. And cross multiplying would work with all of those up to this point. It would not work with this here. Now, as we look at this, we're not going to treat it any differently than we have up to this point. Now, restrictions, we'll actually look at these, unlike the last 2 where I just gave those to you. Because our restrictions for this here, we would look at the denominators. And there are 2 variables, 2 spots where we have variables in the denominators. And they're actually both just x. So in either one of those spots, if x is equal to 0, we'd have a division of 0, so it doesn't work. So really, x cannot be 0. Now the one denominator of 4, because there's no variable in this spot here, it does not have a restriction because there is no value of x that would make that denominator be 0. Nothing we can do there. Now let's figure out what we need to multiply everything by. So if I look at the negative 9 over x, if we multiply it by x, we would have negative 9x over x, and that x over x would reduce. Because if this is x, it and the x would cancel out, and it would reduce that fraction. But we can't just multiply that one term by x. We've got to multiply everything by it. Every single term, we've got to distribute all the way through. So we know that's for sure. But before we start multiplying anything else, let's just make sure nothing else cancels. Nothing else simplifies. Up to here, it hasn't, but let's check and make sure. Our middle term, 7/4, well, this would be 7x over 4. Nothing reduces. And the other term, 5x over x, well, this x over x would indeed reduce. So just by multiplying by that single x, we reduced two of the fractions. However, it did not reduce the middle one. So what else do we need? 4. So we're going to have to multiply everything by 4. And by doing this, the middle term's denominator of 4 will cancel out with that 4 also. Now have all the denominators been reduced? Well, yes. Is this the mathematical approach? Not really. It is and it isn't. Because the pure math way to do this is we would look at x, 4, and x, those three denominators, and look for the greatest or the least common multiple, or least common denominator. Come to the fact that it's 4x, we multiply everything by 4x. Same thing, it is just not the same approach. Because we didn't find the full term all at once, we found it part by part. And all we're left with now is 5 times 4 plus 7 times x, or well, 7x is equal to negative 9 times 4. Well, really, 5 times 4 is 20, plus 7x is equal to negative 36. The first thing we need to do to solve for x is 2. Subtract 20. 20 minus 20 is 0. Negative 36 minus 20 is going to be negative 56. And last but not least, we would divide by 7, telling us x is equal to negative 8. Now, one of the nice things or things that I like about doing the multiplication term by term that we did at the start is it makes sure we don't put too many in. Making sure that we simplify each one at a time. And another good thing to do, especially with this here, is make sure the denominators are factored. Because if they're not, we could end up adding extra terms that we do not need. One of the restrictions is kind of nice, our x by itself, so it can't be 0. The x minus 5 is really just telling us x cannot be positive 5. Because 5 minus 5 would be 0. So if x is positive 5 or 0, those would be restrictions. We'd throw those solutions out. Now looking at the equation, what do we need to multiply everything by? X minus 5. And we have to multiply everything. And the reason we're multiplying it is so that the x minus 5 under the 8 will simplify out. What else? X. And we're doing that so that the one on the right, x will cancel. What about the 1? Do we need to do anything with it? No. It doesn't matter that it's 1. The big thing is that it does not have a denominator. It doesn't have a bottom of fraction to simplify, to reduce. There is no fraction there. So I'm not even concerned with what that is. Doesn't matter if it's 1, 7, x squared. Whatever that term is fine because it does not have a denominator, bottom of the fraction. Questions on how we started this? Now, 1 times x minus 5 is just x times x minus 5. Minus. We have our 8, and the only other thing being multiplied with 8 is x. So 8x equals 3 times x minus 5. So after we multiplied through by the x times x minus 5, we're left with this. X times x minus 5 minus 8x is equal to 3 times x minus 5. Now we need to solve. So for the x times x minus 5, we can distribute the x. X times x is x squared. X times negative 5 is negative 5x. Minus 8x equals 3 times x is 3x. 3 times negative 5 is negative 15. Questions on this here? And again, just like with the last one, because we do have a quadratic term, an x squared term, we will need to get this equation equal to 0. But before we do, it might be nice to get our like terms. We want to combine those. Now we can start moving things from one side to the other. So the first thing we can do, or one of the first things we can do, is subtract 3x. Then we can add 15. Giving us x squared minus 16x plus 15 is equal to 0. Use those parentheses with 3 spaces. Since the third term is positive, the signs are the same and match the sign of the middle term. Negative and negative. Factors of x squared are x and x. Factors of 15 are 1 and 15 or 3 and 5. One and 15. Because x times negative 15 would be negative 15x. Negative 1 times x is negative x. Negative 15 minus 1 is indeed negative 16. Negative 15. Since these are integer answers, could we have actually used the graphing calculator to graph it and get these? A dead giveaway, or a more likely giveaway that we're going to have integer answers, is if the value of a is 1. Because if we're going to get rational results, we need a number in front of x that we have to divide by at the end to get there. So if that a is different than 1, there's a good chance we're going to have fractional answers. But if a is 1, we're going to get integer answers. So we could graph it if it does have integer results. Now, that's not always the case because we could have irrational or complex. And in those cases, the calculator will still tell us that, but it tells us that by it did not cross at nice points, or it doesn't cross the x-axis at all. So if it doesn't cross the x-axis at all, that means there's no real solutions for that quadratic equation at that point, which means there are no real answers. There are no answers, real solutions for the rational equation. And at that point, there is no solution. There should not be one. Let's look at this one. What do we need to multiply through by? 2 and x. Let's go green. Because for this one here, the far left one, the x and x would cancel. In the middle, the 2 and 2, and the far right would be the x and x. Really leaving us with 3 times 2 plus 5x, 5 times x equals negative 12 times 2. Or really, we can just say that 6 plus 5x equals negative 24. We would then subtract 6 minus 5x is equal to negative 30. That's it. Questions on this here? Questions on anything we've done so far? And really, this isn't any different. These aren't any different than what we've been doing. So really, that is it for at least this part. We'll delve more into it on Monday when we actually start looking at these here that have extraneous solutions and that have denominators that we need to factor.